Hello everyone. Today's topic of discussion is deflecting torque and angle of deflection for PMMC type instrument. Here we'll learn about the derivation of deflecting torque and the angle of deflection of the pointer. We know there are three types of torque or force which are required for the operation of the PMMC type instrument. The torques are deflecting torque, controlling torque, and damping torque. Deflecting torque in PMMC type instrument, when the current is flowing through the moving coil, there is force acting on the two leg of the moving coil. Force on one side of the coil is F equal to BIL into N. BILN. Here B is the flux density in the air gap, I is the current in the coil in ampere, L is the effective axial length of the coil in meter, B is the breadth of the coil, N is the number of turns of the coil. Torque on each side of the coil, torque we know torque is calculated by force into distance from the axis of rotation. We know force force is equal to BILN. So force is BILN, and distance from the axis of rotation, it is B by 2. B is the breadth of the coil. So from the axis of rotation to the axis of rotation, distance from axis of rotation is B by 2. So T equal to BILN into B by 2. So the total deflecting torque exerted on the coil is TD equal to 2 into torque on one side. So it is equal to 2 into BILN into B by 2. So it is calculated as T equal to BILN Newton meter. So for a permanent magnet, flux density B is constant. Also for a given coil, axial length L and breadth B and number of turns of the coil N are constant. So here B is constant, L is constant, N is constant, B is constant. Small b is constant, capital B is constant, L is constant, and number of turns N is constant. Therefore, we can write TD equal to K1 into I. TD equal to K1 into I. So this is the equation for deflecting torque. Now we'll derive the equation for controlling torque. Here controlling torque is provided by the control spring. Spring control is used. Two phosphor bone spring S1 S2 are used. One is attached with the spindle above the soft iron core and another one is placed below the soft iron core. The controlling torque opposes the deflecting torque. In some instrument, it is seen that the control spring also used as used to conduct the current into and out of the coil. The control torque of the spring is proportional to the angle theta. TC is proportional to angle of deflection theta. So we can write TC equal to Ks into theta, where Ks is the spring constant. So final steady position of the pointer, we know control torque equal to deflecting torque. These two torques must be equal at the final position of the pointer. So TC equal to TD or Ks theta equal to K1I, or we can write theta equal to K1 by Ks into I. K1 by Ks, K1 is constant, Ks is also constant, so constant by constant, it is we are taking K is another constant. So theta equal to K into I. So theta is proportional to I. So angle of deflection theta is proportional to the current flowing through the instrument. As it is as theta and I has proportional relationship, so that the scale is uniformly divided. Scale division is uniform for PMC type instrument. So from this lecture we will see the derivation of the deflecting torque and also the derivation of the angle of deflection theta. Thank you. That's all for today's lecture.